Hello, and welcome to the first in a series of videos to help you design, build, and compete in many structure building competitions, such as some of the events in Science Olympiad. Today we'll start off with the basics of choosing wood, since this is a fundamental piece that will help you understand why certain designs, wood sizes, joints, and ideas do and don't work. So let's get started. When choosing building materials for competition, we tend to want to use the strongest materials available. This gives us an advantage over the competition since our structure, be it a bridge, tower, or other, will be unbreakable and stand up to anything we throw at it. The issue is that most competitions have rules that guard against this, and force us to use better materials for the job, and perhaps a bit more brainpower. When I did Science Olympiad, I tended to want to use bamboo to build my bridges and towers since it's so damn strong. The issue is that it isn't technically a wood, and is also specifically banned in the rules. Rules like this restrict us to just a handful of woods to choose from, the main two being basswood and balsa. When it comes to the strength of the two woods, bass is almost always stronger, since it has a tighter, more consistent grain and is much denser. Balsa, on the other hand, has far less consistent grain patterns and densities, making it much more difficult to build our structures from. And that's exactly why we use balsa over bass. Not for its oddities and shortcomings, but for the good qualities that come along with them. Let me explain. In most competitions, and I'll use Science Olympiad as an example, there are lots of rules that make the competition more fair to all participants and better suit the spirit of competition and learning. Thus, the scoring for the competitions is usually a ratio of structure weight to the weight the structure actually holds before failing. That makes us use materials that have higher strength to weight ratios, and, well, balsa fits that to a T. Bass tends to be much stronger than balsa, but when you need to have specialty parts that have different strengths and weaknesses throughout your structure, then you should probably use a material that gives you those variations, and that's balsa. So if you're looking for a video to help you with a basswood structure, then this is where it ends for you. Bass is a great wood for many projects, but for competition structures, it has almost no place since we can find balsa that mimics the properties of bass when we need it. Now let's get to the reason you're here, to find out how to choose wood for your structure. First, let's learn about the types of grains, because I know that's really what interests you. Just bear with me. Depending on how you build your structure, you'll need to consider this information more or less strongly. If you're using non-square pieces of wood in your design, then listen up. Otherwise, the grain pattern isn't as important to you. So there are three general types of grains: A grain, B grain, and C grain. A grain, also called tangential cut, has grain lines running through the width of the sheet. These grains are parallel to each other and tangent to the circles centered on the middle of the log they were cut from. This makes sheets flexible and good for compression and tension along the width of the sheet. B grain is also called random cut or rift cut. This is because it isn't cut in any particular direction with respect to the center circle I mentioned earlier. This grain has oblique lines which mix the properties of A and C grain. That is why it's semi-rigid both across the width and the thickness. C grain is often called quarter cut, and it's the opposite of A grain. It has parallel lines down the sheet which make it very strong for some applications. It is very stiff across the sheet, but splits easily, and is therefore a bad choice for compression and tension across the sheet. With that in mind, let's move on to sizing. Again with Science Olympiad as an example, we tend not to want to use pieces that are too large for our purposes. We want our structures to fail, just as we hit our maximum load. Sizing our pieces so that our members are not too thick or too thin means that we can accomplish just that. The two most used sizes of balsa are 3/32 inch square and 1/16 inch square. I'll call them 32nd and 16th for short, even if it's improper. Many teams have realized that when it comes to members that hold most of the load, 32nd is the way to go. This is due to its rigidity and strength before bending. 16th, on the other hand, is used mainly for supports. This is because it has only 4/9 of the area of 32nd and is therefore more than 2 times weaker. It is, however, much lighter due to the smaller cross-section, and can be even lighter when you choose the right density of wood. It is more versatile yet, since rigid and semi-rigid pieces can be used with great success for compression members and trusses. The less dense pieces tend to be more spongy, but act really well for light tension members. One of the most important things to do when choosing wood is to go out and hand-select everything. I'm not kidding about this. You need to know how to select wood for every last member of your structure. If you're new to this, then don't be overwhelmed. It took me 2 years to realize this in high school. After watching this video, it's only taking you a few minutes. So hopefully from the last section, you well enough understand why these densities matter. Now, to testing. I bought one of these cheap scales online for about $10. It has a least significant digit of 1/10 of a gram, which is more than enough. We only really care about testing down to the nearest gram, since we will be sorting our wood into piles for every 5-gram increment. Just make sure your scale can measure at least 50 grams. Now, I do this measuring all in store before I buy my wood. This can be a little awkward when people stare at you and the store clerks ask you what you're doing, but it's the best thing to do if you want to get exactly the wood you need. Also, remember to get at least 20% more wood than your design calls for. This is good for when you make mistakes, produce waste, or break some pieces while dueling your friend. Anyway, here's how I test my wood. I only test for compressive strengths, since it's difficult to test for tensile strengths, and I don't really care about them. Most pieces have a far better tensile strength than you'll require, which is why I mentioned earlier that I use those crappy spongy pieces for my tension members. So, on to testing. Make sure that you can tear it on a flat stable surface like the floor. And good. Set it to grams, because who the hell knows what 2.79 ounces means. Now, I generally use all the stuff I talked about earlier to help me with a preliminary choice of wood. I feel every piece by gently squeezing them on both ends and rolling them between my fingers. This is to help determine if it's a rigid or spongy piece and about how rigid. I feel both ends to make sure that the stick has a consistent density down the length, since imperfections and density changes can ruin your structure. I'm only looking for strong pieces today, so I'll only grab the ones that I think are the strongest. Now, once you're happy with your preliminary selection, take a stick and press it down onto the scale from one end with the other end resting on the scale. Try to keep relatively vertical and don't worry if the stick begins to bend. This is expected and necessary. The first couple of times, you're going to break the pieces. That's okay too, you're just a noob. Just learn to feel how the wood responds to pressure, and listen for any creaks or cracks when you're applying pressure that will tell you when you're about to break the piece. Once you see that the reading on your scale has stabilized and doesn't change when you push down anymore, you have found your maximum compressive load. This is the number we will use to split up our wood. Now of course, these readings are going to differ with different sizes of wood. You will tend to find 2-foot-long pieces in most stores, and I will give you some rules of thumb for compressive loads of 32nd and 16th. Now, I'm looking for 32nd pieces that have a compressive strength of more than 30 grams. It is rare to find any above 35 grams, but I'd really like those. For compression members, I tend to use 32nd pieces that are stronger than 30 grams. For tension members, as I've mentioned before, I tend to use spongy pieces. These are generally less than 10 grams strength for 32nd and bugger all for 16th, but you can just feel them to know that they're right. They are, well, spongy. Many support pieces and trusses can be made with semi-rigid wood. Today, I'm looking for fairly rigid 16th for my support members, so I'm going to look for anything above 11 or 12 grams. This is because of the cross-section I talked about earlier. I use the same principle to determine the strengths of 16th normalized at 32nd. I just divide the strength I'm looking for, say 25 grams, by 2.25, our area factor, and get 11.1 grams. You can also roughly estimate this by halving the strength, since our area ratio is 4 to 9, 16th to 32nd. That just about covers everything you need to know about choosing wood for your competition. If you have any questions or comments, leave them in the comment section below. I hope you learned a lot and saved 2 years of your high school career in the process. And make sure to stay tuned for more videos in the series.